welcome to the class today. We're having some topics on measure of central tendency. We're having the mean, we have mean of ungrouped data, we have mean of grouped data, and we have the weighted mean. We're going to start with analyzing what mean is all about. Mean is all about averages. For example, you're in a certain class. You have like 20 students in the class, and the sum of the ages of those students in that class, probably this total sum of their ages altogether is about 4,000. That's sum of their ages. But the number of the student is 20. Number of the students. So from here, the average or mean, or you call it average mean, is 4,000 divided by 20, which will give us 200. So that's average age, which we know it's not possible to have 200 as age of our student. Now, mean, as it said, is events. If, for example, we have events that are x1, x2, x3, x4 down to xn, meaning n can be anything. Now x1, x2, x3, x4, xn. From here I can take my mean, which is denoted as x with a brick, is equal to x1 plus x2 plus x3 plus x4 plus xn, all divided by n. Now, why am I dividing by n? Why am I dividing by n? The reason is because you have to add all the values of the data divided by the number of the data. Just the way you have the sum of the number of the students in the class divided by their number. So that gives you the average or the mean. So the mean of any event or data is by x down to x1 plus x2 plus x3, x4 down to x and divided by n. Now, that's that. So from there we can now continue to talk about the fact that I can derive a formula now to talk about arithmetic mean. Now, for that mean we'll now have mean for group data. For group data, let's start with that. For group data, the mean for group data is x summation x over n. What is the meaning of summation x over n? Summation x over n means if I have data like 1, 2, 3, 4, 5, 8, 11. 1, 2, 3, 4, 5, 6, 7. Now, if I want to find the mean of this, what I need to do is my summation x divided by n. This value here, you call summation, is called sigma. Sigma. So, sigma x divided by n will give me values like 1, plus 2, plus 3, plus 4, plus 5, plus 8, plus 11, all divided. Then let's count the numbers. 1, 2, 3, 4, 5, 6, 7. So when you count that, that will be divided by 7. Now that gives you the value of, so that is for data that are ungrouped. Now, let's now consider data that are grouped. Now from there, you have values to add that to. So automatically from here, summation of all these values that we see are called ungrouped data. They are not grouped. So data are not grouped generally. These data are just 1, 2, 3, 4, 5, 6, 8, 11. They are not grouped. But when you group a data, it's a different case entirely. So anytime you are given data that are not grouped, your summation is EXN, which is summation of this divided by the number. Now, that will take us to say another example of such, where you have values that are, if you have given something of this nature, maybe you are given data of 4, 3, 1, 8, 8, 6, 5. Now, what is your mean? The mean of this value is equal to, the mean of this value will give us, that mean of this value becomes 4 plus 3 plus 1 plus 8 plus 8 plus 6 plus 5, all divided by, let's count the numbers, 1, 2, 3, 4, 5, 6, 7. That's divided by 7. It's not always 7, it can be any number. So, what about you are given values like 4, 9, 8, 0, 3, 2, 1. Now, from here, and you have 12. So from here, your mean becomes 4 plus 9 plus 8 plus 0 plus 3 plus 2 plus 1 plus 12, all divided by 1, 2, 3, 4, 5, 6, 7, 8 divided by 8. So that's mean. That's mean for ungrouped data. So always remember, mean for group data is summation, is bar x equals to the sigma x divided by n. Now that's that. Let's consider mean of data that are grouped. So basically for group data, we've talked about mean, we've talked about mean of ungrouped data. Now let's talk about mean of group data. Group data are data that are used to. For example, you are told that the numbers of students, maybe you are having 10 to 14, you are having 15 to 19, you are having 20 to 24, you are having 25 to 29, and you have 30 to 34. You observe that between 10 to 14, these kind of data, whenever you see them, they are called grouped data. The reason is because they are arranged in order. That makes them group data. But unlike the one we treated initially, they are ungrouped, they are scattered. They are just like that. You are the ones to pick them together. But these ones, they are already grouped, arranged orderly. So because they are, if you look in between these two guys now, you observe that what is in between these two guys is 10 to 14. The difference between them is 4. 15 to 19, in between them is 4. 20 to 24, in between them is 4. 25 to 29, in between them is 4. And 30, 34, in between them is all 4. But what about, in this case, all the occurrences, the frequency of this occurrence? Maybe the frequency of this occurrence is probably, we have here to be 4. Maybe the occurrence of this is like 6. Occurrence of this is 2. Occurrence of this is 1. And the occurrence of this is 3. If you have something of this nature, you observe that these are group data, but these are their frequency. So this value starts from frequency. So, and these are the marks or sizes. Now, take a look at it. So, the mean of this kind of data which are grouped is E sigma f x divided by sigma f. The sigma fx it looks funny by writing, but it's simple, very easy to understand. All you just need to do, whenever you see the word sigma, this sign sigma, sigma means summation, sum them together. Now, and you are having f. If you look at the word f statement fx, this fx means f times x. That's what it means. So it shows that you are going to sum all the f times x together. That's what it means. Sum all the f times x together. So here, what it means is that sum all the f together. Now, if you have to sum all the f times x together, you have to sum all the f together. So from there, you will discover that these are what they call grouped data. Now we're going to take example of, so take note of this formula as formula for calculating mean for data that are grouped. Now let's consider question on data that are grouped. Now if you look at this, if for example you are told to take your calculations based on data that are grouped, what you do is from here you can have fx. If for example you have a tray where you have your marks, you have your marks to give you values, and you have your frequency. So what you are having here is you are having this to be a 20. You have your 20 value. You have your 10 down to 14, and what it gives to me is 4. I'm having values that will give me. Now if you're having this and you're having 15, 19, and you're having 6, 20, 24 gives me 2, and 25, 29 gives me 1, and 30, 34 gives me 3. So from here I can calculate something called cumulative frequency. The word C stands for cumulative, F stands for frequency. So if I want to calculate cumulative frequency, all I need to do is 4 plus 6, that's 10, 10 plus 2, that's 12, 12 plus 1, that's 13, and 13 plus 3, that's 16. So now CF, which is cumulative frequency, is equals to 16. Now that's for that. Now after considering this, you take note of this and you take note of your cumulative frequency. Now we'll consider a question that has to do with mean of ungrouped data. Good. Now, we have a question on mean of group data. Now for mean of group data, you take a look at these values. You have 53, and the frequency, which is the occurrence, is 10. 55, the occurrence is 18. 60, weighted, occurrence is 12. 67, weighted, occurrence is 8. And 71, weighted, occurrence is 12. Now, it's simple. From there, all you need to do is to create a table. And that table will look like this. The table will look like this. Now, for the value of the weight, which is the max, we represent it with x. So you still see the values are repeating itself: 55, 53, 60, 67, and 71. Now, for the frequency, represented 10, 18 in correspondence. Now, from there, it's easy for us to say that we have to calculate, first of all, the value of the summation of fx. So we have to find f times x. So f times x is the multiplication of 53 and 10. F times x. So whatever you get from the multiplication of these two, you put it on this row. So 53 times 10, that gives me 530. 5518 990. 6012 is 720. So I'm still calculating fx. So by the time you are done with the whole value of calculated fx, so the last value is 7112, that is 852. So from 852, you discover that by the time you sum everything together, which is this word, summation. So by the time you sum all of them together, 530, 990, 720, 536, 852. By the time you sum them, everything gives you a total value of 3628. Now that is the value of summation fx. So summation f itself, which is just net under summation f, if you add it, you have 10, 18, 12, 8, 12. By the time you add, you have the value of 60. Now that brings us back to mean, which is bar x. Bar x is summation fx divided by. So whatever we got at this fx, which is this, we place it here, 3628 divided by 60. So automatically the total weight, which was the calculate the main weight of the whole of this group data, gave us 60.47 kg. Now we're done with this, so we want to talk about something else, and which is called the weighted mean. So from here we can talk about the values. Weighted mean. Weighted mean is mean that it's used for decision making actually. Weighted mean, for example, you want to buy two models of a phone. For example, you want to buy an Infinix phone, or you want to buy one phone of two different models. Now when you want to buy phones of two different models, you observe that you will look at the weighted mean. Weighted mean can come from different directions, in the sense that probably that phone, the camera, you can look at the camera of the phone. Probably the camera of the phone is 36%, maybe for phone 1. Maybe you have phone 1, maybe the cam is 36%. It's a weighted mean. Then maybe you have phone 2, the cam is about 24% on weight. Now if you consider probably you consider speed of the phone. If you consider the speed of the phone, probably the speed of the phone is 28%, and probably the speed of this one is about 18%. So these are some of the things you consider before you buy the phone. Those things you consider unconsciously. This phone, does it have this? Does it have that? All those things you're talking about, they are weighted mean. So the weighted mean is a mean where some certain data weigh far more than, or weigh slightly or far more than other data. Now here I want to talk about that in details. It's possible the weighted mean is weight 1 for this, and this. That's the formula for calculating that. Now, example, it said a company pays its salespeople. They pay this, and they pay this. It said the corresponding weight is, meaning corresponding weight means 14 for 4 naira 50 kobo, 10 for 3.5, then 2, 5 naira 50 kobo, which is corresponding. It said the corresponding weight is this, respectively. It said determine the weighted mean. So the weighted mean, applying this formula, is the first one is 4.5 to 14. That's it. So the weight and the corresponding weight. The weight and the corresponding data. So you have the weight and the corresponding data plus weight and corresponding data. W standing for weight and corresponding data, divided by 14 plus 10 plus 2. 14 plus 10 plus 2 is the weight. So you have 14, 10, 2. That. So that will give us 63.35 plus 11 divided by 26. So by the time you do this, you observe that the weighted mean for this value is 4.1 9. So that is the weighted mean. And that is our last on this unit of this topic. So you can take any calculation based on this as far as weighted mean is concerned. Thank you very much. I'm your instructor.